This video is about factoring from standard form. So in factoring, the equations need to be in standard form. Standard form means that the terms are in order from greatest exponent to least exponent. So ax squared plus bx plus c. The most common way to factor and the easiest is when your leading coefficient, so the a value, the value in front of x squared, is going to be 1. So how we factor? First, we have to make sure the equations are in standard form. Second, we need to identify the b and c values of the equation. Then we're going to create a factor box, which really just looks like an x, and we're going to put the c value on the top and the b value on the bottom. So you need to see what multiplies to the c value and adds to the b value, and then you're going to place each of those numbers with an x in parentheses. So let's do some practices. So here, our b value is 5 and our c value is 6. So we need to know what multiplies to 6 and adds to 5. So two numbers that multiply to 6 are 2 and 3. And when I add those together, I get 5. So in parentheses, I'm going to have x plus 2 and x plus 3. I'm going to use positive signs or plus signs because both numbers were positive. So let's try another example. We have 20 and negative 9. Now, two numbers that multiply to 20 are 2 and 10. However, when I add 2 and 10 together, that gets me 12. So that's not going to work. I need two different numbers that multiply to 20, which are 4 and 5. Now, the thing I have to be careful about with 4 and 5 is that I'm not adding to positive 9, I'm adding to negative 9, which means both of these numbers have to be negative because I have to fit both rules. I have to multiply to a positive 20, which two negatives multiply to a positive 20, and I have to add to a negative. So both of these numbers in this case will be negative. So I'm going to have x minus 4 and x minus 5. Now, when we're multiplying to a negative number, like in this case, our c value is negative 24 and our b value is 5, we're going to have one of each sign. So we need one positive number and one negative number. If you're adding to a positive, like we are here, the bigger number is going to have to be negative. So two numbers that multiply to negative 24 could be 4 and 6. The problem with 4 and 6 is if I have 6 plus negative 4, that doesn't equal 5. So I need a different combination. So I'm going to try 8 and negative 3. Well, 8 times negative 3 is 24, and 8 plus negative 3 is 5. So we would have x plus 8 times x minus 3. One more example here, we have negative 18 adding to negative 7. So again, we need one of each sign, but this time the bigger number is going to be negative because we're adding to a negative number. So two numbers that multiply to negative 18 are negative 9 and 2. Those also add to negative 7. So we would have x minus 9 times x plus 2. So let's try some more examples. Number one, we have x squared plus 10x plus 21. So our c value is 21 and our b value is 10. Two numbers that multiply to 21 are 3 and 7. Those also add to 10. So when I factor, I would have x plus 3 times x plus 7. Next one, two numbers that multiply to 5 and add to 6. So two numbers that multiply to 5, the only two numbers that we know that multiply to 5 are 1 and 5, which is a good thing because those add to 6. So we would have x plus 1 times x plus 5. Number 3, I need two numbers that multiply to 30 and add to negative 11, which means both of my numbers are going to have to be negative in this case. So two numbers that multiply to 30 are negative 3 and negative 10. But when I add those together, they don't equal negative 11. So I need to try a new combination. So if I have 30 and negative 11, two other numbers I know to multiply to 30 are negative 5 and negative 6. And those do add to negative 11, so I'd have x minus 5 and x minus 6. Number 4, x squared minus 8x plus 16. So I need two numbers that multiply to 16 and add to negative 8. So two numbers that multiply to 16 add to negative 8, they both need to be negative. So I'm going to try negative 4 and negative 4. Those multiply to positive 16 and add to negative 8. So we would have x minus 4 times x minus 4. Number 5, x squared minus 8x minus 21. So if we are multiplying to negative 21, I'm going to need two numbers that multiply to negative 21 and add to negative 8. So I need one of each sign. So two numbers I know multiply to negative 21 are 3 and negative 7. I want negative 7 because my 8 was negative. However, these numbers don't add to negative 8. So that combination is not going to work. The only other numbers that I know that multiply to negative 21 would be negative 21 and 1. These also don't add to negative 8. So in this case, if I can't find a combination that works, this is not factorable. Number 6, I have x squared minus 5x minus 6. So I need two numbers that multiply negative 6 and add to negative 5. So the thing that most people are thinking about right away is, oh, negative 2 and negative 3. While those do add to negative 5, the problem is that they don't multiply to negative 6. They multiply to positive 6. So that combination isn't going to work. So instead, the only other two numbers that I know that multiply to negative 6 are negative 6 and positive 1, and those add to negative 5. So I'd have x minus 6 and x plus 1. Number 7, two numbers that multiply to 14 and add to negative 5. So my larger number needs to be negative, so let's try negative 7 and 2. Those do not multiply to positive 14, but they do add to negative 5. So that combination is not going to work because it needs to fit both rules. Another combination that we could try then, and the only other combination that multiplies to 14, is negative 14 and positive 1. But again, those do not multiply to negative 5. So again, this is not factorable. So let's skip over number 8 and let's go to number 9. So I need two numbers that multiply to negative 11 and add to 10, which means this time my bigger number needs to be positive. The only numbers I know that multiply to 11 are 11 and negative 1, and those add to 10. So I'd have x plus 11 and x minus 1. Now, when we have problems where there is an equal sign, this means we're going to have to solve the equation. So first, we're going to do our box factoring, and then we're going to use the zero product property. We only use the zero product property if there is already an equal sign, and the directions will always say solve the equation. So in these, it's going to say factor and solve below. So we're going to start doing what we were doing. So I need two numbers that multiply to 50 and add to 15. So two numbers that multiply to 50 are 10 and 5. So I'm going to have x plus 10 times x plus 5 equals 0. So when I use zero product property, remember each set gets set equal to 0. So x plus 10 equals 0, x plus 5 equals 0. So we can subtract 10 from both sides in the first equation. We get x equals negative 10. Subtract 5 from both sides in the second equation, and we get x equals negative 5. Remember that the shortcut with zero product property is if you see the sign and it's an x by itself, you can always just switch the sign to get what x is equal to. So number 11, we have 12, and there's no number, but there is a negative sign, so this is a negative 1. So we need two numbers that multiply to 12 and add to negative 1. So I need two positives and a negative. Two positives that multiply 12 and add to a negative. So if I have 3 and 4, -3, -4, those multiply to positive 12, but they do not add to -1. Any combination that I'm going to try here is not going to be able to work, so this one is not factorable and therefore can't be solved. Number 12. I need two numbers that multiply to -30 and add to -13. So two numbers that multiply to -30 that most of us are going to think about right now are 10 and 3. But I need one of each sign if I'm multiplying to 10. So if I multiply these, only add to 7, so that's not going to work. There is another combination that works to 30 that most of us don't always think about as factors of 30, which are 15 and 2. And because we're adding to a negative number, we need the bigger number to be negative. Those two numbers together do add to -13 and multiply to -30. So we'd have x minus 15 equals x minus 15 and x plus 2 equals 0. We're going to split the equations to solve for x. So x plus 15 equals 0 and x plus 2 equals 0. We can add 15 to both sides in the first equation, so x equals 15. We can subtract 2, so x equals -2. Number 13, we need two numbers that multiply to positive 20 and add to -8. So when I look at this, two numbers that multiply to 20 are 4 and 5, but those don't add to -8. Another combination I could try that multiply to 20 and add to -8 are 2 and 10. Problem is that they don't add to -8 because they're multiplying to a positive. Even if I try 1 and 20, that's still not going to work. So again, this one is not factorable. Now, 14 and 15, these are not set equal to 0. So in order to factor, we need to get them set equal to 0 first. So I'm going to add 18 to both sides. X squared plus 11x plus 18 equals 0. Now that it's equal to 0, I can factor. So I need two numbers that multiply to 18 and add to 11. And those numbers would be 9 and 2. So we have x plus 9 times x plus 2 equals 0. So to use zero product property, we're going to split the parentheses, each equal to 0. So we have x plus 9 equals 0 and x plus 2 equals 0. So I'm going to subtract 9 from both sides, x equals -9. I'm going to subtract 2 from both sides, x equals -2. So in the final problem, in order to get it set equal to 0, we need to subtract 12x from both sides. So when I subtract 12x from both sides, I get x squared minus 12x plus 36 equals 0. So I need two numbers that multiply to 36 and add to -12, which means they're both going to be negative. Two numbers that multiply to 36 are 6 and 6, and they're both going to be negative, which does add to -12. So in my parentheses, I'd have x minus 6 times x minus 6 equals 0. I'm going to split these up to equal 0. Notice that it's the same thing in each set of parentheses, so my x will be the same. I'm going to add 6 to both sides, so x equals 6 in both equations.